Hello guys, welcome to Apex Math. My name is Bino. In this video, we have an equilateral triangle ABC with a circle of a center O inscribed, such that NC is equals to 1 and segment MN is tangent to the circle and perpendicular to the side AC. We have to determine the side length of this equilateral triangle. We know that in an equilateral triangle, the centroid, incenter, and the circumcenter all coincide at the same point. This means that the center of the circle is also the centroid of the triangle. Since the centroid divides the altitude in a ratio of 2:1, this helps us link the altitude to the inner radius. We divide our altitude from the centroid or the center in a ratio of 2:1, and from the center to the base we have our radius r. So from the center to the point A we will have 2 times the radius. So the altitude or the height denoted by the letter H will be equals to 3 times the radius, or rather the radius will be equals to 1/3 multiplied by the height. The altitude or the height h of an equilateral triangle is also equals to the square root of 3 divided by 2 multiplied by the side length. So we can denote the side length with the letter S. So this will be multiplied by S. We substitute the height into the formula R is equals to 1/3 multiplied by h, but in the place of the h, let's substitute the square root of 3 divided by 2 multiplied by the side length S. And we have R is equals to the square root of 3 divided by 6 multiplied by the side length S. We will use this formula later on. From our diagram, we extend a radius to that point of tangency, and it will be perpendicular to MN, and another radius to that point of tangency, and it will be perpendicular to the AC. We end up with a square of length R, and at that point of tangency we call it point P, and P will be the midpoint of the side length AC. So Pn will be one of the sides of the square with length R, and our PC will be equals to Pn, which is equals to R, plus Nc, which is equals to 1. Since P is the midpoint of the side length AC, our side length S will be double PC. So our S will be 2 multiplied by R plus 2 multiplied by 1, which is equals to 2. So we substitute the highlighted R into this formula, and our S will be equals to 2 multiplied by R, but in the place of the R we substitute the square root of 3 divided by 6 multiplied by S plus the positive 2. On the left hand side we have the S, and we move this term from the right to the left, and the 2 divided by 6 will be 1/3. So we have negative the square root of 3 divided by 3 multiplied by S. This will be equals to 2, and 1 minus the square root of 3/3 will be equals to 3 minus the square root of 3 divided by 3, all of which will be multiplied by S, and this will be equals to 2. So we have to make the S the subject. So we multiply both sides of the equation by 3 divided by 3 minus the square root of 3 Finally, our s will be equals to, so that 3 and that 3 will cancel out, and 3 minus the square root of 3 will cancel out with that 1, and our s will be equals to 6 divided by 3 minus the square root of 3. We can leave our answer here or we can rationalize. So let's rationalize. We multiply by the conjugate of the denominator. So we have 3 plus the square root of 3 divided by 3 plus the square root of 3. And our s will be equals to the 6 multiplied by 3, which is equals to 18, plus 6 multiplied by the square root of 3, which is just 6 multiplied by the square root of 3, and in the denominator, 3 multiplied by 3 will be equals to 9, negative the square root of 3 multiplied by the square root of 3 will be equals to 3, so our s will be equals to, but the 9 minus 3 is equals to 6, so we can just substitute 6, and 18 divided by 6 will be equals to 3, plus 6 times the square root of 3 divided by 6 will be equals to the square root of 3. So our s will be 3 plus the square root of 3 units. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content interesting.